Okay, so today's mini lesson is all about solving equations with variables on both, or excuse me, on one side. All right, so this should say, I'm sorry, this should say same sides. Okay, so what this is going to do is connect ideas that we've seen so far in class with solving equations. So the last couple of days, think about what we've done. On Friday, we started off with just, this is last Friday, started off with just moving a number over. So getting rid of addition and subtraction, dividing our answer by -1, okay? On Monday, we started off by talking about, all right, well, what happens when I don't have just a -1 in front? I move some things over and divide by a different number. Maybe it's 2, 3, maybe it's -2, -3, whatever it may be. And on Tuesday, the last mini lesson that we had, we incorporated the distributive property. So we said, all right, we have to distribute first, then get rid of our addition, subtraction, then get rid of any multiplication, division, and solve. So you see that we started off way back when with these building blocks of combining like terms, distributive property, all that stuff. And now each time that we come together and solve an equation, we're adding that extra layer into our process. Today is no different. So today what we're going to see, if we're solving equations with variables on the same side, we're taking our idea of combining like terms, applying that, and then using it to help us solve, okay? So that's kind of the introduction into what we're going to be doing today. Does anybody have any questions about that idea? Okay. So just like we have been doing, what I want to do is do an example first. We'll come up with a list of steps. All right. And then we will go through and do a couple more examples. Isaiah, do you have a question? You're gonna say the answer already? All right, well, hold on. All right, hold off for a second, and then I'll come back to you when we're ready. All right. I like that though. I'm glad that you're eager to participate. So if I'm taking a look at this for example, I have 3x plus x equals 28. All right. Now it looks like, or it appears that maybe we have two variables in our equation. We don't. We have the same variable, right? It's just showing up one time or two times. We're going to have to use our idea of combining like terms to add those two things together. So if I, on the left-hand side, have 3x plus x, what does that give me? 4x, right? So 4x on the left-hand side equals 28. Is there anything I can combine on the right-hand side, or is that good by itself, 28? It's by itself, right? Well, traditionally, in these equations, the first thing I would want to get rid of is any addition and subtraction. So if I'm adding anything to my variable or subtracting, I want to get that to the other side, right? We've seen a lot of examples like that up until this point. Well, is there anything that's being added or subtracted to my variable right now? No, right? But what's being multiplied or divided to that variable? What's in front of my variable right now? 4, right? That number that's out in front. Technically, these are being multiplied together. Well, what should I do to get the variable by itself? What do I do to undo that multiplication? What should I do on both sides? Divide by 4. Isaiah, what do you think the answer was going to be? 7. Exactly right. So what did you do to start your process in your head? Exactly what we just did?
Yeah.
Okay.
I did the plus the x, and then basically just divided by 4.
Exactly. So you went through it on your own, which is great. And I'm glad that we're taking that step to kind of see, all right, well, what do I notice? I notice I have common terms, so I can combine them, right? Like if you saw parentheses, the first thought that should go up is, all right, well, maybe I can distribute here to start, right? And little by little, as we start to go through these problems, it's going to become that way where we see a process that we know, and we can kind of just expand on that to help us solve. So my answer is x equals 7. Now, if you were to plug that back in, what's 3 times 7? What's 21 plus 7? 28, and I would have 28 equals 28 on both sides. So I know I have the right answer, right? Again, every time that you get a solution, you can check it by plugging into the original equation. And if you get the same thing on both sides, your answer is correct, okay? Any questions about that first example? So let's form a list of steps. What was the first thing? So Isaiah, you already pretty much described it, right? What was the first thing that you did in your head there? You said, I did this to start. 3x plus x. And what's that process called? So we're doing addition, but what kind of, they're common terms, right? So the first thing that we did was combine like terms. So if we're making a list of steps for ourselves off to the side here. We want to combine like terms. All right. And you're going to see this in your ALEKS assignment. That's all right. No worries. You're going to see this in your ALEKS assignment later on. That's going to be your first step for each problem, is to first combine like terms. The second question I asked you was, is there any addition or subtraction with that, right? And there wasn't, but sometimes there might be. Maybe not today, or maybe not in your assignment, but moving forward, we still want to get rid of any addition or subtraction. And the third step, when we divide it by 4, we get rid of any multiplication or division, right? Those steps are always going to follow each other to get that variable by itself, right? Essentially, that's our plan when we do those 2 steps. Okay. The last step is to simplify and check your answer. So just like before, that's always going to be your last step. Simplify and check. Okay. Any questions about that first example or the steps that we created? Okay. Take a look at the next example. I have 8y minus y equals 28. If my first step is to combine like terms, how would I do that on the left-hand side? What's it going to simplify to? What's 8y minus y? 7y. Is there any addition or subtraction to get rid of? No. Okay. So then what's the next thing I need to do? Divide by 7 to get rid of any multiplication and division. 28 divided by 7? 4. That would be your final answer. We're almost done, so it's no point handing it out now. To check your answer, you took 4 and plugged it back in. You have 8 times 4. What's 8 times 4? What's 32 minus 4? 28, right? And I would get 28 equals 28 on both sides. Right? So then I know I have the right solution. Let's do one more example here, because I think by now we probably understand this process, right? So what's the first thing I need to do? I have 4x plus 5x equals 72. What's my first step? Add these together, and what do you get? 9x. What do I do from here? Divide by 9. And what's 72 divided by 9? 8. Good. If you were to check your answer, you plug in 8. 4 times 8 is 32. 8 times 5 is 40. What's 32 plus 40? 72. And I get 72 equals 72 on both sides, right? Each time, like I said, you get a solution, make sure that you go back, plug it in, and check your answers. To recap, let's go through our steps. Combine like terms, get rid of any addition, subtraction, get rid of any multiplication, division, simplify your answer and check, all right? Really straightforward process that you can apply to any question that you have today, okay? Are there any issues with that? Any questions, comments, or concerns about what we've done today in class?